Our objective in this lesson is to be able to identify congruent figures and corresponding parts. Congruent figures are figures that have the same size and shape. All the parts of one figure are congruent to the corresponding parts of the other figure. For example, in these two triangles, do we think they are congruent? Well, I see a lot of measures. Let's take a look at what we see. In this triangle, side AB says 12, and in this triangle, side NT says 12. Similarly, there is a side that says 8 and a side that says 8. And in the top triangle, there is a side that measures 10, and there is a side that measures 10. So we do have 3 sides congruent to 3 sides in the other triangle. But what are the other parts? The angle measures. This angle says 41 degrees, and it is congruent to this angle that says 41 degrees. This angle B says 58 degrees, and in the other triangle we have an angle that says 58 degrees. Now we have to make sure that these angle measures, or these congruent angles, are in the corresponding parts. Meaning, if this side has a 12 on it and it's connecting the points A and B whose angles measure 41 and 58 degrees, this side that has a 12 has to connect the points whose angle measures have 41 and 58 degrees, and as we see, it does. Then we have angle C that measures 81 degrees, and over here there's an angle that measures 81 degrees. Now, the side that uses point C, for example, side AC, connects 41-degree angle and an 81-degree angle. That's the side that says 10. Let's look over here at the side that says 10. It also connects the 41 and the 81-degree angle. So we do have congruent triangles here because the corresponding parts are congruent. Let's list over here the corresponding parts that we said are congruent. Remember that the corresponding parts are a pair of sides or angles that have the same relative position in two congruent figures. So remember that we said that AB measures 12 and NT measures 12. So equal measures, we would write that AB equals NT, which equals 12. The congruent corresponding parts would therefore be segment AB is congruent to segment NT. Notice that when we put a measure, we use the equal signs and no hats because this means a length. And when we say congruent, we're talking about the segments themselves, not involving a number. Similarly, we have segment BC measuring 8 and segment TO measuring 8. So I would write under the measures column that BC is equal to TO, which equals 8 units long. Over here, the congruent corresponding parts would be segment BC is congruent to segment TO. And finally, the third side, AC, is congruent to segment NO, since both of those segments measure 10. AC equals NO, which equals 10. Now looking at the angles, angle A and angle N both measure 41 degrees. So the measure of angle A equals the measure of angle N, which equal 41 degrees. Again, I use the equal when I'm talking about the measure and I involve numbers. Over here I would write that angle A is congruent to angle N. These are the congruent corresponding angles. Angle B is 58 and angle T measures 58. So angle B is congruent to angle T since the measure of angle B equals the measure of angle T, which equals 58 degrees. And finally, angle C is congruent to angle O since the measure of angle C equals the measure of angle O, which equals 81 degrees. Since we have congruent corresponding parts, we can write a congruence statement. This tells us that the figures are congruent and which parts are correspond. So triangle, I'm going to go alphabetically. In the first triangle, ABC is congruent to triangle. Now when I write the next part of the statement, I have to make sure I match up the corresponding parts. So remember how we said A matches with N, corresponds with N? That means N will go first. B corresponds to T, and C corresponds to O. So we make sure that we write it in the correct order. Let's take a look at these examples. Use the pictures to write a congruence statement, if possible. So I notice that I have 3 sides congruent to 3 sides, but I only see 2 angles congruent to 2 angles. However, because of these intersecting lines, I know that the vertical angles are congruent. So now I see 3 angles congruent to 3 angles. Therefore, I can write a congruent statement. Let's start with the triangle to the left and go alphabetically. DEG is congruent to, D has the 1 angle mark, so I must match it with its corresponding angle. So I start with H, so triangle H. I went to E, which has the 3 angle mark that I made because of the vertical angle, so that corresponds with angle E in the other triangle. And finally, the third angle F. So here's my congruent statement. Triangle DEG is congruent to triangle HEF. How about in picture number 2? Well, notice that these 3 sides are congruent to each other, but in the other picture, I'm not using the same congruent marks. So I don't have congruent corresponding parts here. So in this picture, it is not possible to write a congruent statement. I don't really have enough information. Find the value of x and y. Notice the given congruent statement. Triangle ABC is congruent to triangle FGH. Now I notice that x is on a side, and that is the side that connects points F and G. Looking at my congruent statement, F and G are the first 2 letters, so that means that side corresponds to side AB. So I look where side AB is, and it's this side right here. So I know that this side is congruent to this side, and therefore x plus 1 has to equal 5 because those will be the same measures. Let's solve this equation. And I see that x equals 4. How about y? Well, y is in the angle that says F, and F corresponds with A. They are both in the first positions. A says 46 degrees. So since angle F is congruent to angle A, I know that the measure of angle F, which says 2y degrees, has to equal the measure of angle A, which says 46 degrees. And then I can solve that equation. Divide both sides by 2, and I see that y equals 23. How about number 4? Given the following figure, find the value of x. Well, I see congruent marks. So this one congruent slash says 30 degrees, therefore this one congruent slash says 30 degrees. This double congruent slash says 110, so this one has to be 110 degrees. And then I know that the 3 angles in the triangle have to add up to 180 degrees. So I know that x plus 110 plus 30 equals 180, and x plus 140 equals 180 when I combine the like terms. So 180 minus 140 makes 40, so x has to equal 40 degrees. Notice that these two angles, say 30 and 110, and these two angles that had the congruent marks now say 30 and 110. And in any triangle, no matter what, the angles always have to add up to 180 degrees. So instead of having to transfer these angles over to here, if I know that two angles are congruent to two angles in another triangle, then the third angles in this triangle would both have to be 40 degrees because they all have to add up to 180 no matter what. Therefore, a quicker way to think about this is that when two angles are congruent to two angles, then the third angles have to be congruent. And that's called the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Let's do number 5 and use the third angles theorem to solve for x. Now notice I have intersecting lines. So that means these two angles, the vertical angles, have to be congruent. These are vertical angles. Now that I know that two angles from the top triangle are congruent to two angles from the bottom triangle, then the third angles must be congruent as well. Therefore, x has to equal 65, and I don't have any arithmetic to do. That makes things a lot easier. Finally, let's take a look at some properties of congruence. The first one that's very useful is the reflexive property of congruence. For the reflexive property, think about a reflection. When you see your reflection in a mirror, you see the same thing. You see yourself. These are two triangles that are connected by side AB. Triangle ABD and triangle ABC both use side AB. It is congruent to itself. We would write segment AB is congruent to segment AB, and it would be useful when showing corresponding parts of congruent triangles. How about in this picture? Do you see the two triangles? There are a lot of triangles, but here are the two that I'm pointing out. Triangle AED, AED, and the other triangle, CDE. See those two triangles? CDE. Notice which side both triangles share? That's right, it's this bottom side that's congruent to itself. So we would say that side DE is congruent to itself. Often, you'll see it written so that it's in the order for corresponding parts. So side DE is congruent to side ED. Still, it's the reflexive property because it's the same exact side. In the third picture, we've got two triangles overlapping. The one triangle, AEC, and the second triangle, BDC. Now this time, the two triangles are sharing angle C. It is congruent to itself. Angle C is congruent to angle C. These are three examples of using the reflexive property. Now there's two other properties. We don't use these too often, but they're helpful to know. The symmetric property flips the statement around. If AB is congruent to CD, then CD is congruent to AB. So think of that as flipping it, kind of like the converse. The transitive property, AB is congruent to CD, and if CD is congruent to FC, Then we take out the middleman and connect AB to FC. AB is congruent to FC. Does that look familiar? Think of transitive like transfer. See that part of the word in there? And that's like the law of syllogism. Let's see how we can use some of our new theorems and properties. Use properties or theorems to mark the pictures with any extra information about what might be congruent. Then write a congruent statement if possible. So in this picture, I notice there are two triangles, triangle AZM and triangle BZM. They both use this side ZM, so I can mark that it is congruent to itself, and I would write that segment ZM is congruent to segment ZM by the reflexive property of congruence. Now that I have that, I've got three congruent sides, congruent to three congruent sides, and three congruent angles, congruent to three congruent angles. So I will say triangle AZM is congruent to triangle. Now we make sure the parts match up. A has two slashes, so I start with B. I went from A to Z, so I go from B to Z because those have the same congruent marks. And then finally back down to M. Remember that we said that these segments are congruent to each other, so these segments ZM should be in the same positions in our congruent statement. Let's take a look at the next one. Because I have intersecting lines, I know that these angles are congruent. These are my vertical angles. So I'm going to say angle HYJ is congruent to angle BYN, and that's by the vertical angles congruence theorem. Well, I only have one pair of angles, so I have to look for something else. Notice that I have parallel lines. These symbols mean parallel. So that tells me that I can find congruent angles, such as these two angles, angle H and angle B. These are alternate interior angles. Now sometimes we can extend the lines to help us, and sometimes it's more helpful to notice this pattern. If I trace the parallel lines and the transversal, it creates a Z shape. So the Z shape always gives me the alternate interior angles. So I'm going to write that angle H is congruent to angle B because of, or by, the alternate interior angles theorem. Now I could have done the Z the other way, this way, using side JN as a transversal, and that would have given me these angles congruent. So also, angle J is congruent to angle N by the same theorem, alternate interior angles theorem. Finally, now that I have everything marked, I can say that triangle HYJ is congruent to triangle BYN. Make sure I match up the corresponding parts. H goes with B because they have the same marks, Y goes with Y because they have the same marks, and J goes with N because they have the same marks. Finally, I have almost everything marked in this picture except for these angles. Why can I say that angle S is congruent to angle Q? Because of the third angles theorem. Now I can make a congruent statement that triangle KSL is congruent to triangle AQP. Of course, I make sure that the corresponding parts match up. See, K and A have the same marks, so do the others. Thanks for watching.